Hey, what's going on, guys? In this video, what we're going to be doing is we're going to be taking a look at one of the problems on my website. This is actually the second of a series of problems in the constant acceleration section. So the problem reads, just as a car starts to accelerate from rest with acceleration 1.4 meters per second squared, a bus moving with constant speed of 12 meters per second passes it in a parallel lane. How long before the car overtakes the bus? B, how fast will the car then be going? And C, how far will the car then have gone? So essentially, this is a kinematics problem, and it's a one-dimensional problem. We're just focused on two particles here, right? We can sort of reduce the bus and the car to two particles, and then we can just analyze their motion, and we can apply the equations over here to see to see how the basically how the car and the bus move, and then be able to answer the questions from that. Okay, so let's start with A. Part A asks us to find the time it takes before the car overtakes the bus, right? So the car starts to accelerate, okay, and it's accelerating from rest, right? So the acceleration of the car is 1.4 meters per second squared. So let's start by first, let me write down that this is part A. And let's start by writing down our given information, okay? So the first given information is that the acceleration of the car the acceleration of the car is 1.4 meters per second squared. So we'll just write A sub C for car is equal to 1.4 meters per second squared, okay? We're also told that the car accelerates from rest, okay? So what this tells us is that the initial velocity of the car, or the initial speed of the car, is 0. So we can write V0 of the car is equal to 0. Right? Now we're also told that a bus is moving with constant speed, right? And the value or the magnitude of that speed is 12 meters per second, okay? So we can say V0 of the bus is, I'll put a capital B for the bus, is 12 meters per second. So we'll just put 12 meters per second here, okay? So in order to find out how long that it takes before the car overtakes the bus, we have to realize that just as the car starts to accelerate, the bus just passes the car, okay? So initially there's going to be a certain distance between the car and the bus, okay? So to reduce this diagram over here, make it a little bit more simple, we can represent the car with a red dot over here and the bus with a blue dot over here, okay? So suppose a certain amount of time t passes, okay? After a certain amount of time t, obviously the bus is going to be a certain distance ahead of the car, okay? So maybe we can say after a certain amount of time t, the bus might be here. Okay, so there's a certain distance between the car over here and the bus over here, okay? Now, this distance, we can call it v times t, okay? Because v, in fact, let me write over here, the distance over here is going to be v of the bus times, let's see, v of the bus times t, okay? So we have to also keep in mind that the car is constantly speeding up, it's accelerating, okay? So initially, yeah, the bus is going to be a few meters ahead of the car, but after, there's going to be a certain point in time when the distance between the car and the bus becomes 0, because the car reaches a certain speed such that it's able to overtake the bus. So we're looking for the point in time where the car once again lines up with the bus, okay? So when this happens, right, the distance that the car would have traveled and the distance that the bus would have traveled with respect to their starting distance is going to be the same. Okay, so the way we can represent this mathematically, let me move this up a little bit. So the way we can represent this is by saying that x of the car is going to be equal to x of the bus after a certain time has passed, okay? Now, the car is moving with constant acceleration, okay? Which means that the equation for x of the car has to be equation number 2. It has to be of the form of equation number 2. However, for the bus is traveling with a constant speed. So the distance traveled by the bus is going to be the speed times the time in which it travels, okay? So if we substitute x sub c with this equation over here, we can write v0c times t plus 1/2 a sub c times t squared plus x0c, right, the initial starting point of the car, is going to be equal to, let's see, v0b, the initial velocity of the bus, multiplied by t, plus x0b, okay? So this is the initial starting point of the bus, okay? Now we're taking this initial starting point to be 0, all right, just to simplify the equation. Remember, the distance that they travel is relative to that starting point, okay? So that starting point could be anything. However, the result is going to be the same. So we might as well choose the starting point to be x equals 0, okay? So we're just going to erase x0c and x0b because they're equal to 0. And we can then bring this closer to this. Let's erase the plus sign too. And bring this up here. Okay, so this is the equation that we have to solve in order to get the time, right? The t over here, I mean, obviously once we group everything together, we're going to have a quadratic equation, and we're going to have to solve for the time, probably using the quadratic formula. But essentially, this is how you set up the problem, because what they're asking us is to find the time when the x distance traveled by the car is equal to the x distance traveled by the bus, okay? So let's go ahead and plug in the values and see what we can get. Let's see. Okay, so V0 of the car is equal to 0, right? V0c is equal to 0. So let me just go ahead and erase this one too. So really what we have is 1/2 AC times t squared is equal to V0b times t. Okay, what we can, since a sub c is 1.4 meters per second squared, taking 1/2 of that is just 0.7 meters per second squared, okay? So what we have is 0.7 meters per second squared times t squared is equal to V0b. V0b is 12 meters per second, so we can say 12 meters per second times t. Okay? So then we can write 0.7 t squared minus 12 times t is equal to 0, right? After subtracting this term and transposing it to the left-hand side. We can then factor out a t and write 0.7 times t minus 12 is equal to 0. Okay? So what this means is that either t equals 0 or 0.7 times t minus 12 equals 0, right? So we get two solutions. The first solution is t equals 0. Second solution you get is by writing 0.7 times t minus 12 is equal to 0. Okay, and from the second expression over here, we have t is equal to 12 divided by 0.7. Okay, so let's see what that comes out to be. Okay, so that comes out to be 17.14. Okay, so what does the t equals 0 second solution mean? What it means is that at time t equals 0, the car and the bus are side by side, right? The distance between them is equal to 0. And which makes sense because at the very beginning at the start of the problem, the bus and the car were side by side. Okay, so this solution makes sense, but it's not what we're looking for. We're looking for the second solution where the car and the bus are once again side by side. Okay, and that occurs after 17.14 seconds have passed. So the answer to part A is t is equal to 17.14 seconds.